Hi everyone, welcome back. In this video we're going to talk about a topic called pseudo-instructions. Pseudo-instructions. With the key word here, the key prefix, is this word pseudo indicating fake, right? We know that pseudo is another word for fake. So what do we mean by fake instructions? Particularly fake assembly language instructions. And I'd like to give you an analogy to start this off, okay? Because I think it seems a little abstract when you first hear this. And I think if we go through kind of an analogy or an example that's kind of independent of assembly language and the processor at first, it becomes a lot more concrete. Okay, so I'm gonna ask you to kind of go along with this and think about a scenario where we're ignoring assembly language and a processor completely. And let's just imagine that we have a tiny little remote car that we've built. Okay, so we've got this like little remote car. Okay. And maybe we've designed this car. It's taking some instructions from someone who's able to control it, right? Some controller. So somebody's here, maybe able to send messages to the car of what to do. Okay, and we can imagine that we can design this so that there's only a few, that there's a small number of instructions that the car is built to take, right? That the car is designed that it can have a forward command or forward instruction, right? Just go forward, right? Maybe it has a stop. Right? If it's moving, turn the motors off. Just stop. Yeah. And maybe as a turn left and turn right command or instructions. So now you can imagine with just these four instructions, you could have the car navigate something, right? Drive around, right? If you need to turn, you turn left, and then you keep going forward, etc. So you've got these instructions. Okay. And we can call this the instruction set. We could say this is a set of instructions that this car has been designed to operate on, right? Now, we might, even though that's our instruction set, we might find it useful to have some additional things that the car can do. Okay, maybe just hypothetically, maybe we want to be able to have the car to have a U-turn such that the car does something like this. Okay, and maybe even more precisely, that the U-turn might be it's going forward, it turns right. Right, it turns right again, and now it's heading in this other direction. So that if this is the front of the car, right, it's now the front is down here. Okay. So we could build we can have some functionality that maybe we have a U-turn command or instruction. Okay. But we don't actually need to vary this instruction set at all. Because the U-turn could be something that just says, you can imagine designing this different ways. But maybe the U-turn is just designed as a turn. Maybe it's just two turn right commands, or you can imagine you can put a forward in there or a stop as well, right? But maybe you just have it turn right twice, and that's facing the other direction. So you U-turn or a turnaround. Right? And so the key thing is to note is we don't need to really build anything new. We don't need to edit the instruction set at all. Okay. Instead, right, we could still make it kind of have an instruction, and we can call this a pseudo instruction. Okay. And in this case, you can imagine that we build something that looks like this. okay, that we've got our whatever, whether it's a person or something sending commands, right? We could have some layer, right, between the instructions to the car and actually the car receiving it or actually doing the operation. Okay, so we can imagine we could have some layer here, okay, such that the person controlling the car can give instructions in whatever way they see fit. They could use front, they can use front, forward, they can use forward, they can use stop, and they can use turn left. Okay, they can use turn right, and maybe they can use U-turn as well. Okay, but in reality, what's going to happen is if the U-turn command comes in, or the U-turn instruction comes in, okay, this layer, okay, will modify that and will actually send 2 turn right commands to the car. Okay. So what we really have is we have something called like basically a layer of abstraction, which is a really common theme in computing. It comes up over and over and over and over again. Is that at this, we're making it easier for somebody to do something. They just want to talk, they want to be able to send instructions to say, I want the car to do this, this, and that, right? And this layer kind of does that work of saying, well, okay, the car only knows about a small number of things. It has a limited instruction set. The car only supports this instruction set of forward, stop, turn left, and turn right. If that's the only thing the car does, right? That's fine, because the car is sometimes referred to as agnostic, right? It doesn't care about this U-turn command. It doesn't have to be aware of it, right? Because this layer translates that into instructions that it can understand. Okay, so the key thing to recognize then is we would call something like this U-turn, we would call this as something referred to as a pseudo-instruction, right? It's not part of the actual instruction set. Okay, and that is exactly what's going on when we talk about with assembly language. Okay, is we often use instructions that the hardware does not actually support. Okay, if you look in the documentation in your ARM quote unquote green sheet, it lists some pseudo instructions. Okay, let's talk about the move one first. All right, just to give an idea of what's going on there. Let's just talk about the move instruction. Okay, the move instruction, right? If I write the move instruction, okay, that is logically sets R0 to equal to the value of R1. Okay, if I use an immediate field, okay, that sets R0 equal to 5. Okay, now let's look at what this is actually doing when we run it. Okay, and I'm going to use a slightly different emulator than we were doing in class, just because it has a better way of showing this point. This is actually a slightly different assembly language, but it looks the same in this case, or pretty much the same. So this is actually not ARM. This is a different assembly language, but it has a very similar pseudo instruction. You'll see why I'm showing this in a moment, because it illustrates this point really clearly. Right? If I go in here and I say move, and I'm going to use a register called T0 instead of R0. T0, and I'm going to set that equal to register T1. Right? So the register is a little bit different in this emulator versus the other ones we're using, but you can tell pretty easily it's the same idea, right? Now I want you to notice something. I'm going to assemble this, right? It's gonna run through that layer, right? We talked about this similar to this layer here, right? Where we have commands that I'm sending in, it goes through a layer, and then we're gonna look at what's coming out the other end, right? And I want you to notice here, this is we have this move command or instruction that I wrote here, and this is what it turns into. Notice it actually turns into an add instruction. It turns into an add instruction. And I also want to point out that notice that this middle register is register 0. Okay. What's actually occurring, okay, what really occurs is we're doing something like this, right? I'm writing code and I'm saying I want to move a register such as R0, R1, right? So R0 equals R1. It's going through a layer, okay? And before it actually runs on the processor, what the instruction it actually sends in here, okay, is an add R0, okay. I'm going to label it like this. I'll mention this in a moment. Where this here is a register that always contains the value 0, right? So effectively what we're doing is we're trying to set R0 equal to R1. And how we actually do this is we say R0 equals equals 0 plus R1. Okay. Now this might seem like we're making it more complicated, but the reason why, right? The reason why it works this way is the processor is already designed to support adding to registers. It's already built, right? So there's circuitry designed to handle adding to registers. Okay, so we don't want it makes it more complicated. There's no reason to support this directly, right? Because we already have all the ability to do this, right? Using what it's already designed to build to implement. So instead of building like extra functionality that's not needed, we can use existing functionality, right? And we could just add R1 plus 0, so it effectively is R1, and set it equal that way. Okay, so that's what's going on when we're using the move instruction. So move is an example of a pseudo instruction. The CPU, right, your processor does not know about it. It's not part of the instruction set. Okay, but you can still use it when you're coding an assembly. Okay. Another example, coming back to this, right? And I'm using this example here that I'm showing is a different assembly language, but it's the same point. They're so similar. It's actually something called MIPS. I'm gonna do this where we say we're adding. So we're gonna say T0 equals T1 plus 100, where T0 and T1 are registers. Okay. And I'm going to run this, and I want to point out, okay, so this is what I coded here, okay? This is what comes out the other end, okay? Now you can ignore some of the things, right? We've got two registers that are labeled as register 8 and 9. That's what T0 is register 8, T1 is register 9. And then we have this, in hex, we have the decimal version of 100, right? 64 is 100 in hex. But the key thing I want you to recognize is that notice I used add here, and what comes out the other end is add I, or add immediate. Okay? Right? The reason for that, okay, is that there is, adding some, we need to actually, the processor needs to support different things, right? And adding, having the processor having the processor needs to do something different if it's adding two registers together versus adding one register and an immediate field. Okay. So we can write the code in a very similar way to make it easier to write. Okay. But what's actually happening, okay, is even though we're writing it in this example, or if we can kind of write it in a similar way, the example on the top will use an add instruction. Okay. Well, the example on the bottom here will use an add immediate. Sometimes people say ADDI, right? Add immediate. Okay. And the reason is we need different circuitry, right? As part of the CPU to determine if we're going to be adding two registers together, right? Versus a register in an immediate field. It's different logic. Okay. It's different logic. Okay. So I want you to keep that in mind because it is important understanding of how things work, right? We will see this when we actually look at the processor later on and look at how it's solving and actually executing logic, right? It's important to understand that you'll really see it about why there's two. We'll actually look at that logic. We're going to look at how things connect and how the processor is organized to be able to see why there's two different instructions because they get processed differently. Okay, and this is the same idea here, right? When we're going into an ARM, right, I can do add, right? When I do this here, I'm really using an add instruction. If I do this, where I do pound for an immediate value, for like whatever value there, the top one here on line 1, that will run the add instruction. But in reality, when I run number 3 here, we'll run an add immediate, a different instruction, right? It's an add immediate. And we've seen in a prior video about actually going through and converting an add immediate from from assembly into binary into machine language. And we can see it even how how the instruction is formatted, right? The different parts, the different bits that are a different part of that instruction. You can really see in that case why the information is split differently between these two instructions. Okay, but just beware. There's that middle layer that is converting what you're actually typing and assembling into what the actual processor is going to see, what the instruction set that the processor supports. Okay, all right. So that's it for this video. We will follow up on this in class, but you ask me questions, watch the video multiple times, right? Whatever you need to do to make sure that this sinks in. All right, and I will talk to you soon, and I'll see you in the next video.